let's see if you guys can answer a few questions from the first two chapters, right? Not a bad idea to do so. So tell me, IBM I operating system, it's called IBM I or IBM I OS. What is the name of the hardware on which it runs? The name of the machine? Say it again.
Oh, I'm sorry.
Name
I'm trying to remember actually.
Oh,
Last
okay.
time last time you told that actually in class.
I know I did.
Yeah, you did. Yeah. So that's I'm trying to remember.
It is called IBM Power System. IBM Power System. That's what it's called.
I thought it was ZOS, but I didn't want to say that.
By the way, what is ZOS, Desmond, that now that you brought it up?
I just because in Alan's class, because I wasn't in their first class, I was with Alan.
That's okay, because you already did the chapter 3 with Alan last week. So it must be a refresher for you when we start talking about chapter 3. So is ZOS something that you see on NyQuil?
Something you see.
There are a lot of Z's on NyQuil, right? No, ZOS is the operating system for mainframes.
Yeah, and then it's kind of unique, I guess would be the word I would use.
Yeah, and what is the CL equivalent for ZOS?
The what?
What is the control language equivalent for ZOS? We learned about that last week. It's right on in chapter number 1. In fact, it's right on the first page of chapter number 1.
Well, let me open my book real quick then.
Yeah, you guys should open your book, definitely.
Oh, really? CL?
No. CL is for
Language. And then there's
CL is for IBM iOS. What is for the mainframe ZOS?
oh, ZOS.
JCL,
JCL.
CL. Yep.
JCL.
job control language.
Exactly. That's for the mainframes. Okay. So ZOS is installed on a machine type that's called a mainframe. So mainframe is a generic name for that kind of a server. IBM OS is installed on a power system, but power system is not a mainframe. So what is it then? It's not a mainframe. So what is it?
Is it just a server or a database?
No. What kind of server? See, mainframes are also server machines. And IBM OS, which is running on the power system, is also a server machine, but it's not in the same league. It's not in the same category. So what is it then? You know, there's an NFL and then there is a college one, right?
Oh,
So
yeah.
yeah, so there are different categories. So what is the name of the category in which IBM OS falls? Have you guys heard of WMCPA?
Yeah.
Okay, WMCPA. What does it stand for? Look that up. What does WMCPA stands for?
Oh, that's the Wisconsin Mid-Range Computer Professional Association.
Okay, so that
That's right.
name has the type of the computer type. Not the full thing, but there is a word in that name that is categorization of this server,
Mid-range.
mid-range. Okay, so we got mainframe, we got mid-range. And the PCs and the laptops and the notebooks and all of that little computers that we use, what is the category for that? You got mainframe, mid-range, and a lot of the people don't know. So I was wondering, maybe you guys know, what do you call these personal computers in all shapes and forms? They fall
Yeah.
under what category?
Yeah, that would have been my answer. They're personal, but there's got to be a different category for it.
Yeah, that category is called microcomputer.
Oh,
Okay, so we have mainframe, mid-range, and micro. So microcomputers are client computers, and mid and main are server level computers. So in 1970s, IBM was using IBM system, fill in the blanks.
okay, back in the 70s.
38.
38, okay. Which in 1980s became
ES400.
AS400.
Okay.
And AS400 was running an operating system called
OS 400.
OS400, okay. And OS400, before it became an IBM I, it became something else. Then it became IBM I.
i5 OS.
No. OS400
System I?
became System I. Okay. System I basically was the equivalent of AS400, but OS400 actually became i5 OS. i5 OS was the name of the operating system running on System I. So IBM iOS is an object-based operating system. So what exactly does that mean, object-based operating system?
Working with objects.
That means in order for you to work with this operating system, you can only work with objects. If it is not an object, you can't work with it. So are commands objects?
No.
Why not?
I don't know.
Commands are part of the control language.
Okay, so is that the reason that they're not objects?
And you use the control language to work with the objects.
Control language can be used in two different ways. What are those two different ways control language can be used? The answer is on the very first page, page 1 of chapter. I'm still on page 1 of chapter 1.
You can type in the commands individually, or you group them together in a CL program.
Exactly. So when you type them individually, that means you are interacting with them. So they must be an object. And when you group them together, then you group them together in a program, which then makes it a CL program. So commands are objects. So are CL programs. But when CL programs are written, they are written as members. And then they're compiled, and then they become objects, and then you can use them. Which command should I use to run a CL program?
Would it be run CL PGM?
No.
Okay, sorry, I was just a guess.
Let's see. Anybody else would like to make a guess? Which CL command is used to run a CL program?
JCL.
No, JCL is a separate language. JCL is a CL-like language for mainframes, and CL is for the mid-range. So which CL command is used to run
Is it call?
call? Yep,
Call.
call. Yep, exactly. You call a program. Always, doesn't matter. It's a CL program, it's an RPG program. Call is the command that you would use. If I'm writing CL program in green screen, which utility will I use?
Start.
If I'm writing a CL
Oh, I see it,
program,
right. Okay.
if I'm writing a CL program in green screen, yeah, go ahead.
SEU.
SEU will be the name of the utility that you would use. And how would you start that utility?
STRSU.
STRSU. Okay. So when you are working with STRSU, you just simply double click on it? Or how does that work?
STRSU, then is it F4?
And then you put F4, right? What happens if you press enter?
It'll bring you back to the last program.
It brings you back to the last member, not
Member.
program, member that you were working with. Okay. So you guys can see my screen now. So which utility should I open, or which application should I open to work with green screen?
The Access Client Solution.
ACS.
Yeah.
Okay.
Yeah.
Now, which programming language is ACS coded in?
Java.
Yes. Which option should I choose out of this list?
5250 emulator.
What do I have to make sure that is selected before I do that?
If you're on desktop.
System.
You.
Very good. I have to make sure the system doesn't say select a system. Rather, the system should have a name of a system.
Yes.
Okay. If it does not has any item in that list, then what should I do? Where should I go to link to a system?
Maybe file. And that was so long ago.
That
System configuration?
you should click on system configurations, and then you hit new, and then you write the name of the system, and you hit OK. And when this comes in this list, then it shows up here in the list. Okay, so let me click 5250 emulator. It will ask me, it will authenticate me before it gives me here, it gives me an access to the green screen. So I enter my username, my password, and I'm okay. What is this thing?
Tells you the last time you signed in.
Yeah, but what is this thing called where I landed?
EIPL.
IPL.
right.
IPL. Okay, what does IPL stands for?
Initial program load.
Initial program load. Very good. So now when I hit enter, the very first menu is your initial menu. Initial menu. Initial menu for us happened to be the main menu. How many regions is the main menu divided into? Did you say anything?
23.
3 regions. No.
I said 23.
23 is also wrong. The main menu,
4.
any menu in this case will be divided into 4 regions, right? The header of the menu is divided into how many regions?
Three.
The header is divided into 3 regions, correct? Okay, so here we have, what is this thing?
The menu name.
And what is this?
The menu description.
And this is the name of the system. So this whole thing at the top is the menu header. Okay. The next thing that you have are menu options. Then you have a command prompt. And what do you have at the bottom?
List of the function keys.
You have the function keys. Very good. Okay. And these function keys can then be used to do different operations here. For example, if I am typing a command, CRTLIB, and I do not know what other information I need to provide, I can hit which function key?
F1.
F4, which is what kind of screen is this? Prompt screen. Okay. What are these things called that I will be filling in?
I want to say fields, but I think it's wrong.
No, it's not fields. Fields is more like a database terminology.
Are they parameters?
These are called parameters. Okay.
That's it. Yep.
Parameters are divided into how many categories? Two. Two. Required and optional. That's it. Required parameters must be provided for you to run the command, and optional do not require anything to be provided. Again, we're going to dive a little bit into that, into chapter number 3 when we start talking about that. But the main reason of a control language program is to be able to help the administrator to run the scripts on day-to-day basis instead of having to sit there and type all the commands and having to do the same job repeatedly. You just write a program in SEU, and then you compile the program, and then you use the program. Which utility do I need to go to compile the program that I write in SEU?
Is it the PDM?
PDM. Okay. So I type str PDM and I hit enter. And which option should I choose?
Work with members.
Work with members, option 3. Okay. Now I have to put file. What kind of file is that?
Physical file.
No,
Is it a source physical file?
it's a
Oh, so-
source,
yeah.
right? Okay. What's the difference between source physical file and a physical file?
The physical files go into the source physical file.
No. For physical file never goes into source physical file. I know what you're saying, but your wording is incorrect.
The source physical file has to be created first before you're allowed to create a physical file.
No. Well, yeah, but physical file, you're missing a word. Physical file dash goes inside.
Physical
Or-
file members. go
Very
into
good,
the
very good,
source
very
physical
good.
file.
That's it. Member. It's a very important word. When you say the word member and when you drop the word member, there's a day and night difference. It's member is not an object, but physical file is an object. So when you are saying physical file goes in a source physical file, if I were to explain to you, like in a database terminology, you're saying that I created the employee table inside the department table, which you can't do. You can't have a table in a table. You can't have an object in an object. So that's why when you say, I am creating a member, the member is what goes inside the source physical file. Okay. So what is that file name that I have on that line? What kind of file is that?
A logical file?
No, no. I am about to create the members. See, I'm about to create the members. And all the members go inside what kind of file?
Source physical file.
Source physical file, okay? So when you're working with this utility, you need to provide the name of the source physical file where you can go and see all the members in it so that you can compile the members that you need to compile. Is everybody following that?
Yeah.
Okay.
Yes.
So that's why when you are working in SEU or you are working in PDM, in both of them, the file is source physical file. Can you see at the bottom of the screen? It clearly states member. That means that's the member area. And right at the top is the source physical file area. It needs to know, okay, you want to work with a source physical file, for example, in my case, FA22SYA, but can you tell me where is it located? So I'm saying, look in the Yusuf S. So Yusuf S is the library, and the source physical file FA22SYA is a source physical file inside that library. And when I go inside the library, you will be able to find the members. Okay. Now, if you look down under member, there's a name which right now set to all. That means I want to list all the members. Type, I want to list all types of members. If I want to only see my physical file members, I can just literally type PF. It will only show me physical file members. If I want to see only logical file members, I'll type LF. Okay. Now you heard a sound. What happened when the sound was played?
Yeah, you clicked out a screen or you went
Yeah,
beyond.
exactly. And then I can hit the control key on the keyboard to get my screen back. And if I type LF, it's going to be only the logical file members. And if I leave it all, that means I want to see all kinds of members. And now when I hit enter, what screen type am I looking at right now?
List.
List. Okay. So in the list screen type on the left-hand side, you have the options and you can choose an option and then you can. Okay. So which option will help me compile my member?
14.
14.
14. Okay. And I hit enter. Okay. When do you see the screen?
When it already exists.
When the object already exists with that name. Okay, if you're trying to convert a member to an object, if there's already an object with that name that exists in the library where you're sending it, I did not use the word source physical file because you cannot send an object in another object. So I'm using the word library. So when you try to create an object in a library and that library already has an object by that name, it'll give you this window in which if I press Y, yes, and I hit enter, notice what it tells me at the bottom of the screen. The following object was deleted. Okay. Was that object also recreated, or do I need to create it again by issuing the command 14?
Did it just
think you're
replace that
good.
one?
Yeah, I'm good. It not only deleted, but it also created right after deleting it. And let me check the status of my command. How can I check the status of my command?
DSP MSG.
Okay, cool. Enter. And now it tells me that the following thing completed normally at 6:39:59. And I'm good. Okay. Function keys at the bottom of the screen. How many total number of function keys do we have? So again,
That 24?
24. And how many function keys do you have on your keyboard?
Oh,
12. So how do you go about the rest of them?
shift.
Shift. Very good. So you shift, and that's how you find the others. I am looking for something. Just 1 minute, guys. Okay. Can everybody see this?
Yeah.
Yeah, okay. Now notice this guy. This is an apsidic keyboard. Do you guys know what is apsidic?
Does it mean it has 24 function keys?
No. What keyboard standard do you guys use? What keyboard standard do you guys use?
Normal one?
Yeah, I was gonna say I got a normal keyboard. I don't know.
It's not called normal keyboard. This one is also a normal keyboard.
No, that's not a normal keyboard at all. That thing has like a whole other keyboard on top of the keyboard.
You guys use an ASCII keyboard.
Yeah,
Okay.
that's the ones we had in Walgreens right there for the AS400s.
Okay. No, the keyboards that you use are ASCII keyboards, and this keyboard is not an ASCII keyboard. It's an IBM keyboard. IBM uses a different keyboarding used a different keyboarding standards called apsidic. Right.
Yeah.
Okay. So apsidic keys are different than ASCII keys. So apsidic, ASCII is American Standard Coded interchange, information interchange, right? And apsidic is extended binary coded decimal interchange code.
Yep.
Now with apsidic keyboards, because that's where the IBM mid-range and mainframes use apsidic to begin with, that's why you have all 24 keys listed at the top. Okay. And then once you can see this, let me scroll down further for you guys and let me clear this stuff here. All right, cool. Okay. Do you see anything different from the rest of the keyboard?
Yeah,
I
there's
think it
different-
might have more function keys.
It has more functions key, of course, but I'm talking about the bottom area. You know, there are a bunch of undefined keys. Do you see that?
right.
It's like
Yeah.
macro keys.
Yeah, so you
It's a
basically
reset
have
key.
you have a choice. You can program these keys. Also, it is missing a key from the last row of the centerpiece, which you have it on your keyboard.
Control key?
Control key, yeah. Now that the Windows keyboards also have window key, and which other key do Windows keyboards have? Function key and
Alt
Also,
alt.
it's a copy.
control.
There's a right click key on some of the keyboards on the right hand side between function and control. And on the left hand side, there's a window key or it's something like that. What other keys do you see different?
We have rule.
Say it again.
Rule.
Yeah, it doesn't have page up, page down. It has roll up, roll down.
And an enter key is where the control key is. Field exits where the enter key was. Yeah, this is bringing back some AS400 memories.
Now, this is the key I'm talking about. This was right here between Windows and all. That's for the right click. Context menu is what we call it. Oops. Ah. Okay. So,
Sure.
also, if you notice on your keyboard versus this one, your keyboard has a home and an end key. This doesn't.
It also does not have escape.
It doesn't have escape, right? It has a reset if you look at the bottom. Yeah, it doesn't have escape though. And it also has an enter key, right? But it has a key called field exit, where you typically have your enter key on ASCII keyboard. And if you look on the left-hand side, there is a system requirement, attention. You have a help, print, play, all sorts of keys that you don't have on Windows. Now start noticing the center part. All the letters are in the same place where you typically have. However, where is the exclamation mark?
Gone. Oh wait, never mind. Next to B.
Yeah, next to number one is not the number one has a pipe symbol. And next to P is the exclamation mark. And underneath the exclamation mark, do you see like a cent symbol? Right?
Yep.
Okay.
Yeah.
Yes, yes, I can see.
And also notice on the left of Z, you have greater than and less than symbols.
Yes,
Yeah. Also notice that you don't have square bracket symbols. Number 6 on your keyboard is a caret symbol. Look at the number 6 here.
Mhm.
Your mic just amplified, like,
You might have switched to your camera's microphone.
What?
your mic just went like super loud.
Oh, is it okay now?
You gotta speak so I can hear you.
I think your mic input device might have changed.
Oh, my mic input devices. So am I super loud or not?
Yeah, you're not like
Crazy loud.
I am. Okay. How about now?
It's better.
Better. Okay. I might have I think I might have moved it from number 2 to number 4 or number 3 or something like that. Anyways. So these APSIDIC keyboards are based on a little different standard. By the way, your ASCII keyboards, anytime you press a key on your keyboard, what signal does the keyboard receives that it sends over to the next level? Let me bring the binary ASCII table. So when you press the letter A on the keyboard, Oh, no, not this one, sorry. No, this will do it too, yeah. Anytime you press a letter A on the keyboard, like this one, it basically signals 65 on the programming. And it signals 0, 1, 0, 0, 0, 0, 0, 1 to the computer level. So 65 is what you would receive at a programming level. This is what you would receive at a machine level, and this is what you have at the human level. So how A becomes 65? Let's try to see how A becomes 65. What is the binary number system's base? What is the base of binary number system?
Just 0 and 1s.
It's base 2 because it has only two representations, 0 and 1. So now for A, the representation is 0, 1, 0, 0, 0, 0, 0, 1, right? So these are the placeholders. So this is the placeholder number 7, 6, 5, 4, 3, 2, 1, 0. These are the placeholders 0 through 7. So when I press an A on the keyboard, A equals to how many bits? How many bits do you see A is equivalent to?
2.
No, bits.
Is it 8?
8. See, there are 8 digits that represent A, so it's 8 bits. And that equals to how many bytes? Eight bits is how many bytes?
1 byte?
1 byte. Okay, so every letter on the keyboard is equivalent to 1 byte. So how does that 1 byte A turns to a 65 is what we are looking at, okay? So now we are looking at all these positions on base 2, as I told you, right? Base 2, base 2, base 2, base 2, base 2, okay. Now these zeros and ones are switches. Whichever switch is 0, that means that item is off. So wherever it's a 0, that item is off. Now for the remaining items, we need to figure out the math. Any number raised to the power of 0 is what?
1.
1. So 2 is the base, 0 is the power, that's 1. 3 is the base, 6 is the power. What is 2 to the power of 6?
Is it 32?
That's to the power of
64.
64. Okay. So if you add all these numbers together, what do you get?
65.
That's it. That's how A equals equal to 65. Look at the B. One shift over. So basically for B, this bit is on and this bit is off. Right. What is 2 to the power of 1?
2.
2. So this is 2 and that's 0. So now 64 plus 2 is 66.
66.
Exactly. So that's how it goes. Okay. Now what is for the C? It is 0, 1, 1, right? right here, 0, 1, 0, 0, 0, 0, 1, 1. So 2 to the power of 0 is 1. Why am I considering this? Because now this bit gone. 2 to the power of 1 is 2. So 64 plus 2 is 66 plus 1, 67. Like that, it is doing all the math. So in the Java class, if I have a character variable whose value is, let's say, E, and I do system.out.println.ch, it will print E. But what we're gonna print for the next one? It'll gonna print 69 because I'm taking a character and I'm casting it to an integer. So all the characters are basically integer behind the scene. So
Can
that,
you do the same thing where you convert the integer to a character then?
yeah. Yeah, so if I want to get an E out of, so I can take 69 and I can cast it to character. So I get an E. That's why there are only 2 data types in programming. One is integer and the other one is integer and the other one is
Is it integer in character?
no, because remember, character is a subtype
String.
of integer,
String.
float,
Float. Oh, yeah.
okay, integer. Those are the only 2 data types. All other data types are derived from it. So since integer is a father of character and character is a father of string, so string is basically an integer, bunch of integers put together. And this is the reason that character is an integer, because all characters basically translate to their integer equivalent when they are sent behind the scene. And that's what makes your passwords case sensitive, because uppercase and lowercase letters have different ASCII codes. So it is matching the numbers. So basically what it is doing, if your password, for example, is A, and you entered A, so it is basically saying, is 97 the same as 65? And of course, the answer is, no, it is not. So that's false. And that's what makes your passwords case sensitive, and it denies you access if you are mistyping the case, even if you are meeting the letter standards. And usernames are not case sensitive. Does that make sense to you guys?
Yes.
Yeah, roughly.
Roughly makes sense to you, Ethan?
Yeah. I'll probably have to watch the explanation over a few times and maybe some more YouTube videos to really fully understand it though.
Yeah, probably. Yeah, this is basically just the math behind it that happens where you convert from characters to integers. Okay. So in a nutshell, that's how the keyboards work on ASCII standards. So when we talk about CL commands, the CL commands are how many letters long maximum?
10.
10.
10.
CL commands are typically 9 letters long, maximum. And what are the 3 areas in which CL commands are divided?
The verb, subject, and modifier.
And modifier. Very good. Okay. So can you give me an example? Can anyone of you give me an example of a CL command with verb only, no subject, no modifier?
Go.
Go. And another one?
Call.
Call.
Call. Okay. Can you give me an example of subject and verb and subject?
strpdm.
STRPDM. Okay, cool. Subject and modifier along with the verb.
Add library list entry, the command for that.
Yeah. So add is verb and library is a subject and list entry is the modifier. Okay. Can your subject be only 1 letter long or does it always has to be 3 letters?
Sometimes it is 1 letter.
Like,
can
for
be.
example,
F for file.
F file. Yes.
yeah, copy file, right? Okay. Can you give me an example where all 3 are filled to 3 letters each?
SND, PGM, MSG.
SND, PGM, MSG, send program message.
Message.
Okay. So typically when you're writing your CL commands, they are written in 2 different ways. What are the 2 different ways in these CL commands are written?
Structured and key.
No. CL commands can be written in 2 different ways.
Keyword and positional.
Keyword and positional. Okay, what is the difference?
Keyword, you have to have the type of the parameter.
Keywords, you have to have the type, the parameters, or name of the parameters rather, and along with them the values. And for the positional, you only list the values. You do not mention the name of the keyword. Okay. So CL commands have parameters. We talked about them. The parameters explicitly describe what a command will do, and parameters are identified by a keyword. So here is an example of a command with a keyword, and in parentheses, you have a value. Some of the parameters are required and some are optional. Required and optional parameters, if you're looking at the help site, you will see that if it is required, it will say in the note section of the parameter that it is required. If it is optional, it will tell you in the note section that it is optional. The positional numbering, it is basically an indicator that when you are using both of these parameters, you got to maintain the sequence. That this will go as a first position and that will go as a second position if you're using a positional notation. So keyword notation, as we talked about, these are some examples of keyword notations. What do you notice between the first 2? That the order of parameters does not matter anymore because it knows what value is going in which position or which value is going in which parameter. So that's why, since you have already mentioned the name of the parameter outside and you are putting the values inside, so it doesn't really matter in what order you write them. Similarly, in the second and the third case, what is the difference between the second, third versus first two? Like third, fourth versus first, second. What's the difference? Besides less parameters. Under what circumstances can you drop a parameter?
If you know the value of the parameter and you know the order of it,
So you can simply drop it?
yeah.
No. You can only drop optional parameters. Okay, so the MDR parameter is an optional parameter, so that's why it was perfectly okay to drop it. So the first two lines included it, and the last two lines didn't. And the last two lines showed you the same norm that as long as you know the keyword, you can switch things around.
Is there a way to tell if the parameter is optional or not?
Yeah, here in the help, see it says optional.
Okay.
Okay, see, MDR is optional. So now moving on to the positional notation. So many, but not all parameters can use positional notation. Keyword is not required. It's shorter to code. However, it is your responsibility to make sure the parameters are listed in the correct order. Parameters are in predetermined order. That's one of the requirements, and order is defined within command. So here it tells you that this must go as a first order and that must go as a second order if you are using both of them. Even though the second one is optional, if you want to only use one, that is the one that must be used. Now, let's say your command has 5 parameters. Okay, so let's say your command goes like this. Command P1, P2, P3, P4, and P5. Okay, so P1 and P2 are required, and P3 through P5 are not required. Okay, but you want to provide the values for only P1, P2, and P5. How would you go about doing that? Under the current circumstances, you'll be like, well, if I do this, then will it be okay? No, it won't be okay if you're using positional notation, because what you are considering P5, it will assume it's P3 because it's the third value in the list. So how can I then skip? This is how you can skip. Any parameter positional you are not interested in providing the value for, you use asterisk N. That means skip over. It's optional, skip over. That's what the next topic on slide 9 is, that you can use the asterisk N special value as a placeholder to skip positional parameters. But you need to use this for keyword, because in keyword you're already defining everything. Okay. Mixing keyword and positional notations. You can mix keyword and positional notation. Once you begin keyword notation, you must use it for all the subsequent parameters. So for example, in this case, we started out with positional and we switched over to the keyword. That's okay. But once you switch over to the keyword, and if you have more parameters after that, then you cannot just switch back to positional again. You have to now follow the keyword all the way through. So it could be mix and match. However, the only requirement is you can only switch from positional to keyword, but not the vice versa. Okay? Now, when we talk about parameters, did you notice one more thing? That it tells you the parameter and it also tells you the parameter type. Means file is a parameter type name. Name is the type. So if you're entering, you have to enter a name. It must follow a name convention that it must be 10 letters long maximum, no spaces allowed, only certain symbols allowed, all of that naming convention it must follow. For example, from RCD, notice the data type is integer. So it tells you the data type or the type of the parameter value. Now look at this slide, slide number 11. One data type is called character. Character means in CL string, one or more letters. So, you know, it's a character string. Decimal means it's a number with or without decimal. Integer means it is strictly whole numbers. What is the difference between integer and unsigned integer? What is the difference between integer and unsigned integer? Integer, for example, if supports a value of 128 all the way through 127, then an unsigned integer means that integer that cannot afford negative numbers, cannot support negative numbers. So now the range will be doubled. It's going to be from 0 to 255. Some languages still have unsigned integers, but not all languages do. Back in the good old days, we had limited memories, so we would fall back to unsigned integers to double the space of integers, because we did not have a data type called long back then. You only had integer or that's it. You know, you could just make it signed, unsigned. So that's the whole thing with signed, unsigned integers, okay? The next item in line is logical. Logical is equivalent to Boolean, 1 or 0, true or false. And name is just like a name. Look at the rules of names. Which special character is allowed in the second and other positions, but not in the first position?
Underscore or a period?
Underscore or period are the only two special characters that you cannot use in the first placeholder. Okay, now let's come to the generic name. A generic name is more like a partial name. For example, if I am looking for user profiles and I want to see the user profiles of everybody who is in the 600 range, can you guys tell me the command I should use to work with the user profiles?
WRKUSR?
No.
That's
Close.
shooting from the hip.
Don't you just add PRF on
Yeah,
to that?
yeah, exactly.
That's right.
Okay, okay. Now, all of your IDs start with what 4 letters?
ITPA.
Okay, and then I'm looking for 500 series, so I put 5, and then I put an asterisk. And then I hit enter. So now I get to see all the 500 series people, all the way through 599. So these are called the partial. Okay. Any CL command would be a command string. Hexadecimal. Do you guys know what hexadecimal numbers are? Hexadecimal numbers have 16 representations, 0 through 9, and then A through F. Which course that you are taking this semester that is very heavy on hexadecimal numbers? You'll use hexadecimal numbers in that course a lot more than you would use in my classes.
Is it Java?
I said you will not be using that much in my classes. But you will be using it in that one particular course.
Microcomputer programming?
No.
Oh, so it's the one class I'm not taking this spring.
In
It's
the,
probably the summer
the
class with the internet
HTML?
programming.
Internet programming.
Yeah. They give me a heads
Internet
up at least.
programming. It uses hexadecimal for what? Have you started using hexadecimal numbers in internet programming yet?
Not yet, but
No.
I think that's what we use for colors
Yes,
and CSS.
it's for colors.
Yep, exactly. Okay, so it's RGB colors, red, green, blue colors. It has 2 spots for red, 2 for green, and 2 for blue. Okay, so actually the first 2 are for red, the next 2 are for green, the last 2 are for blue. So if you have all switches turned on, it will be what color?
White.
White. And if all switches are turned off, they'll be black color. Means all switches are off. No light is getting emitted. Okay. If you have only the first switch on and all others off, what color do you get?
Red?
Red. Okay. Likewise, this would be
Green?
green, and likewise, this would be blue, right? Okay. Similarly, let's see. What do you get out of this?
Gray?
Gray. Okay. How can I make this a dark gray from a light gray? If I move it closer to F's, I get a lighter shade of gray. If it's closer to 0, it's a darker shade of gray. So hexadecimal, and then date. What is the date format that we use on an IBM machines? What date format do we use in the IBM machines? We use ISO format, which is what? What is the ISO format?
Is that the year, month, day?
Yeah.
Okay.
And what is this, a separator between them?
Dash.
Dash. Okay. So today would be something like this. in ISO format. Similarly, you have time, which is hour, minute, seconds. These are the types. So parameter types are listed with each parameter. Um, Okay, can you guys open a web browser and look for control language command finder? Type control language command finder.
Yep, first one, CL command finder.
Yeah, click in that.
Okay.
Okay. Now, this is where, for example, under the find by name, type CRTLIB, create library, and hit go. And then click on the create library link. Now, notice all of these are the keywords for the parameters. And look at the middle column, the third column. It tells you for the first one that the type is name. Second one is system values. Third one is character. Fourth one is a name. Fifth one is a number. Name, and then system values. So it tells you the type right next to the parameter. And each of the parameter is then explained. Okay. And then towards the bottom, you'll see some examples followed by the error messages. Now, in your book, if you go to the back of the book, starting from page 457, page 457, you will see an appendix A that runs for a lot of pages. That goes all the way from page 457 to 530. Okay, so almost 73 pages. That basically, if you start looking through that, you will see that for each command that it shows, it gives you the list of parameters and the error codes. So it gives you the command name, the syntax of the command, and the parameters.
Oh, wow. That's a lot.
And these are not all the commands, though, by the way. But all the commands that the author has gathered over here, he has put them in alphabetical order. So, for example, if you're looking for a command to retrieve message, you should go into letter R first, and then look for retrieve message. Let's see if you can find a retrieve message. When you find it, put the page number in the chat. Retrieve message. Yep, Samuel got it. Okay,
506.
506.
Oh, RTV MSG, gotcha.
Now, in this finder, let me go back to the finder. And in the finder, I want you to look for the same command, RTVMSG, retrieve message. And notice that your book only includes how many parameters for retrieve message? 5, right? However, retrieve message has how many parameters? 14. 14. So it is just some of the commands and not all the parameters for the commands. And the one in bold in the book are the required ones. And this is where you can see that they are required. Okay. Okay. What is a qualified name? A qualified name is when you provide the name of the object along with the name of the library. So for example, I want to display the following member, physical file member, and look for this member inside this library, or look for the, in this, so I've given it the context. So when I give it a context, then, it just makes it a lot more easier, In some cases, let's say you can actually give an entire list of values, like here. I want to, what is RSTOBJ? What do you think that stands for?
Restore object.
Restore object. Okay, I want to restore the object. And does your book talks about RST? OBJ? No, it doesn't. Okay, so restore object is where you are listing the bunch of objects that you want to restore on the from the files, the library and to the following tape. And the first one is where you have mentioned the keywords. The second one is which is positional, does exactly the same job. Also, in some cases, you may have to do complex lists like this one, where you want to restore objects, but you want to restore customers, invoices, and payments objects, but not completely, not fully. In the customers object, you want the first 2 members, and in invoices, the first 2 members, in payments, the first 2 members only. So that's how you have a list, and each item in the list has a list of its own. These are complex lists. Don't happen very often, but you have the option there. It is also possible that some would allow for mixed list, mean parameters of different types. Okay. Next, I want you to read the chapter summary on page number 21 and 22. And give me a green check when you're done reading the chapter summary.
Page 21 and 22, you said?
Page 21 and 22. Everybody got it, but Amruta is still reading? Okay.
I'm done.
Oh, okay. Okay. Do you know how to put a green check?
Oh, yeah, I know that.
Oh, okay, okay.
Okay.
That's fine then. Okay. So now let me share my screen again and tell you that this week you will be you have to complete a quiz. And then you have an assignment. The assignment has questions from pages 22 through 24. On page 22, you have to answer all the review questions. And let me write this here, just in case if you are wondering, okay. upload your answers in a Word document or PDF. Okay. So, and on page number 22 starts exercises, but I'm not giving you all the exercise problem. I'm giving you number 4, number 5, number 8, and 10. For number 4, I'm asking, using appendix A as a reference, list all the parameters, keywords for the following CL commands. Now, it's going to take you a lot of time to list all of them. So use command finder tool. And then you can copy paste from there versus having to type so much. Okay. Everybody follow that?
Yep.
Okay, cool. Then the next one is number 5. Which of the following are CL special values? So that's what you may have to find yourself. And the ones that are, just leave them, and the ones that are not, drop them. Number 8, explain the difference between the two commands. That's what you got to explain. And number 10, you will investigate the command DSP PFM, and then using the keyword notation, write the command to display the content of the file, my file, in the library mylib. So assuming that you have access to a file called my file and in the library mylib, using keyword notation, what will be the complete command that you will write? Just let's see if you can, type the command correctly based on the correct syntax for that command. So those are what you need to turn in for assignment number 2. And yep, that's all for tonight. If you do not have any questions, then you are free to go.
Excellent. We'll see you next Tuesday.
Yep. See you next week.
Have a good rest of your week and weekend. Thank you.
Thank you. Thanks a lot. Good night.
No problem.
See you next week.
See you.
Hey, those questions you said are in the